Good morning, everyone. This is Mrs. Rondo. We're going to be looking at parallel and perpendicular lines. You can pause the video and write down the essential question. Remember, we don't need the learning goal written down, but we will go over that in a minute. Actually, I strongly encourage you to use the Google Doc for your notes today, as it has the pictures and equations already written in it, but it is up to you. You can use your own paper or the Google Doc. We actually have two Google Docs today because we're going to add a CER document onto our notes. So those are both available in Google Classroom. Here we go. We're looking at parallel and perpendicular lines. Our essential question: what are the characteristics of parallel and perpendicular lines? And then our goal is that we can prove characteristics of parallel and perpendicular lines. All right, so we have right off the top parallel lines. This is right here, two lines are parallel if and only if they have the same slope. So if and only if they have the same slope. And there's a picture right over here, two lines that are parallel here. Another key feature of parallel lines is that they never intersect. Never intersect. So they're never ever going to cross because they go at the same rate or the same slope. So they're never going to cross. Then we have just some review from Algebra 1, the formula for slope. We use m to represent slope. And we say it is y2 minus y1 over x2 minus x1. And that's just a review from Algebra 1. And just another quick reminder is that the ones and the twos, the ones meaning it came from ordered pair number 1 and the twos from ordered pair number 2. The slope-intercept form, this is also a review from Algebra 1. This is our most popular, one of our favorite ways to write the equation of a line, y equals mx plus b. Just a quick reminder that m represents the slope and b represents the y-intercept, just in case you have forgotten. Quick review again from Algebra 1. All right, so with that little bit of review, we're going to jump right in. And we are going to write equations here. So write an equation for a line that is parallel to the line given by each equation. So the thing that we know about parallel lines, that key feature right up here, is that two lines are parallel if and only if they have the same slope. So when we go to write our lines, our equations for our lines, we need them to have the same slope. So in order to do that, I need to point out what the slope is. Using my slope-intercept form, y equals mx plus b, I can see the slope is going to be that number in front of x. In this case, it is 2/3. So I'm going to create another equation. I'm going to say y equals. I need it to have the same slope. And that's actually all I need. It's just the same slope. It can have any intercept I want. So I'm going to say plus 37, since that's my favorite number. But you could have chosen any number, plus or minus, whatever you would like. It just has to have the same slope. And so the same thing for b is, we're going to, write an equation for b. The slope on this one is -3. And so the slope for my equation, when I write a new equation for a line parallel, we'll have a slope of -3. And again, you get to choose whatever number. I'm going to say +1. Why not? And then for the final one, again, the slope, this one looks a little bit different because it's missing the plus b. So if it bothers you, you can fill in +0. So then you have y equals mx plus b. Here's my m. I'm looking for the slope. I need my new equation to have the same slope, so I'm going to say 10, and then x, and again, I can choose any intercept I want. So I'm going to do -37. Wahaha. All right, hopefully that is good. Let's continue on to perpendicular lines. All right, so perpendicular lines. This one is, oh, and I lost my picture, but you guys should have your picture there. Sorry about that. Don't know what happened. Magic, it appeared again. There's my picture. All right, so two lines are perpendicular if and only if And this one is a little bit more complex. Sorry, dropped my phone over there on the side. That's precious. It's a little bit more complex. So if and only if the product of their slopes is -1. And what this essentially means is the slopes are negative reciprocals. So we're going to practice it out. Like I said, this one's a little bit more difficult. So two lines are perpendicular if and only if the product of their slopes is -1, meaning the slopes are negative reciprocals. So we're going to look at an example. So I'm going to say the slope of my first line, which I'm going to call A, line A. So it's the slope of line A. I'm just going to argue that it is -3/4. I just made this up just as an example. Okay. Then if this is the slope of one of my lines, the line that's perpendicular to that must be, must be the negative reciprocal. So since my original slope was negative, if I do negative of a negative, that makes it positive. So I'd have a positive. And then the reciprocal of 3/4 is 4/3. So essentially what you end up with is your two slopes. You need one positive, one negative, which I have, and a reciprocal. So that's basically how the slopes work out. And we're going to practice it in a minute as well. So there you go. Something I did miss and I want to jump back to for a quick second is on parallel lines. We use the symbol. The symbol we use for parallel lines is two little L things like this. So I'm just going to make a note there that little symbol means parallel. And we'll see that in a minute. I'll use that. And then perpendicular, the symbol for that one in geometry is kind of an upside down capital T. So perpendicular. I also want to clarify on perpendicular lines that they meet at a right angle, which is why I needed that picture. So that is a 90-degree angle. At where they intersect is at 90 degrees. So perpendicular lines mean you have 90 degrees in your problem somewhere. All right, let's jump into the examples. We're going to write an equation for a line that is perpendicular to the given line, or to the line given by each equation, excuse me. All right, so the key is, again, to look at the slopes. We just went over y equals mx plus b. So we have that, our slope-intercept form. So we're going to be focusing on the slope. The y-intercept for this doesn't really affect anything. It just, we just need the slope. So great. So let's look at this. If my original slope is 2/3, when I go to write my new equation for the line that is perpendicular to that, I need the reciprocal, which would be 3/2. And as it says, I need the negative reciprocal or the opposite, or as I mentioned a minute ago, one has to be positive and one has to be negative. Since this one's positive, the negative version is just negative. So -3/2 x, and then again, you can pick whatever number you want. I'm going to stick with my plus 37 because that's my favorite number. And then let's take a look at example B. Same kind of thing. We're focusing in on the slope. In this one, when I go to do the negative reciprocal, I'll start with the reciprocal. First of all, if I want a reciprocal, I need a fraction. Reciprocal means we're going to flip that fraction. So I'm going to start by putting a 1 under it, like so. I'm actually redrawing my circle so we can see that fraction. So it's -3/1. So if I do the reciprocal of that guy, I would get 1/3. Well, it would be -1/3. But then I need the negative version of a negative, which really means positive. Or if you look, one negative and one positive. There's my slope. And then I can do, again, any number. I'm going to say +4 this time. And then for my last one, again, focusing in on that slope, and I'm leaving a little bit of space since it's not a fraction. I'm going to make it a fraction, 10/1, which means when I do the negative reciprocal, the negative reciprocal would be -1/10. So 10/1 flips to 1/10, and then the negative version of 10 is -10, or the opposite, or one positive, one negative. And then similar to what I did before, we'll do negative 37 because I just like 37. All right, so there's a couple more examples I want to go through. Here we go. Determine whether the two lines are parallel, perpendicular, or neither. This is going to look very similar to your homework tonight, looking at parallel, perpendicular, or neither. So if they are parallel, then they would have the same slope. If they are perpendicular, they would have the negative reciprocal slope, or neither is not going to meet either requirements. So when I look at my first set, first thing on all of these, looking at y equals mx plus b, I'm going to be focusing on the number in front of x, which is my slope. First thing I'm going to check, are those slopes the same? Are they the same? No. Okay, so this is not, these are not parallel lines. They're not the same. Then I'm going to look for perpendicular. For perpendicular, I need a negative reciprocal. So I need one positive and one negative. When I look at those two slopes, they are both positive, so they cannot be perpendicular. I do have a reciprocal, 3 or 3 over 1. So remember, the slope would be 3 over 1 and 1 over 3. Those are reciprocals. But unfortunately, they are not negative reciprocals, right? So we don't have the negative. So this answer here would be neither. Neither. They don't fit either characteristic. Again, we needed it to be negative reciprocals, and we didn't have the negative. All right, let's take a look at B. I'm going to go through that same process again, focusing in on the slopes. And the first thing I notice is those are not the same. So therefore it is not parallel. Then I'm going to look at, focus in again on the slope 1/2, and then I'm going to write this -2 as a fraction. And I'm looking for, again, negative reciprocals. Sorry, reciprocals, there we go, reciprocals. Okay, and I definitely see a negative version, so I have positive and a negative. So those are opposite signs, that's good. Got it. And then reciprocals 1/2 and 2 over 1. So these actually fit the requirements. So this one would be perpendicular. Perpendicular. Then I go to the last one again, looking at the slopes on this one. And this one, it should be quick and easy. Those are in fact the same. So this is parallel. And that's it for our notes for today. I'm just going to check these off because those are the things we checked. Fantastic. I think that's it. Great. Have a great day, guys. We'll see you later.